Hello guys, so let's discuss today's POTD, that is 2598, smallest missing non-negative integer after operations. So the problem statement is you are given a zero index integer array nums and an integer value. In one operation, you can add or subtract value from any element of the num. The example is given. If the nums is 1, 2, 3 and value is 2, you can add 2 in 1, 2 or 3 or in any number of times. Also, you can subtract this value in the given elements of the array. So you have to find the max, that is minimum excluded of the array, that is non-negative integer, and you have to return the maximum max. That means maximum minimum element excluded that is not present in the array. So the maximum element that is not present in the array, that should be minimum. So the example test cases are 1 minus 10, this array is given and the value is 5. So you can add any number of times or subtract any number of times 5 from the elements of the array. So suppose you subtract, you have to find the maximum non-positive element, maximum non-positive integer. So you will always add add the value in the negative integers that are present in the array. So we can't subtract minus 10, we can't subtract 7 in the minus 10 because it will go negative. So we will add this 5 in this negative element, and when we add 5 two times, then we get 0. So 0 is present now, 0 is present in our answer, and 1 is also present. And when we subtract 5 from 7, we will get 2. So 2 is also present. Now when we subtract 5 from this 8, we will get 3, and 3 is also present in our array now, and we cannot get 4 by subtracting or adding this value any number of times in any of these elements. So our answer will be 4. So the constraint are high, means our O of n square solution will not work. We have to find O of n log n or O of n solution. So let's move to the coding part. So what I'm doing is, let's understand it with an example. Suppose I have elements of the array are 3, 6, 7, and the value is 5. So what I'm doing, observing, means we have to find some observation in this for the solution. So if we cannot subtract 5 because we will get the negative element, that will not work, means that will not put any effect in our answer, in our solution. So we can keep this as it is, or we can add 5. So currently we will keep this as it is 3, and if we now in 6, if we subtract 5, we will get 1, and similarly in 7, if we will subtract 5, we will get a 6, 7, 2. So the 0, we cannot get the 0, means so our answer will be 0 for this test case. And what we are observing is that the remainder we are getting, if we can subtract or add any number of times this value, means the value which we will subtract from the element will be multiple of this given value. So we will always get the remainder. So what we are doing, or what we can observe from this is, we can store the simplest form, means the remainder of these in a map. So that is what I'm doing here, and why I'm doing this, so that I can handle the negative values. Means there is a minus 10. If I will do the mod with 5, I will get minus 5, and I'm adding this 5 again. That means I will get the 0, and then I will do the mod with the 5. Then I will get the 0 as our simplest form, or as the remainder. So I'm doing this, I'm storing the remainders of the given element of the array in a map. So suppose the remainders are 1, 2, 2, 3 and 4. This is the remainder and the value is 5. So it is stored in the map. Now what I'm doing is I'm iterating from 1 till I am not able to find our answer. Means when I will find our answer or when this condition will hit, I will return the I, because it is our answer. So I'm starting from the minimum element, that is 0, that I can get, and I'm checking if I'm able to find the I mod value in our map or not. If I'm not able to find it, then I will return this, because this will our answer. And why I'm doing I modulo value here, because there can be multiple remainders of same integer. Means there can be like this, here are two remainders that has value 2. So 2 2. Why this? Because in our map there can be an element like 12 and 7. So both these element will have remainder 2 when we do modulo with 5. So means I can subtract, I can make 2 and 7. Means I can make 2 and 7 for our array. So that's why I'm using the modulo here. Means I can make this multiple elements, like if there is 5, so the value is 5 and the remainder is 1 and 1. This means that I can make, if there is an element that is 6 in my array, then I can make a 1, and if there is 11 in my array, then I can make 6 also. So I can make these two elements. That's why I'm doing the modulo here. Again, I'm doing the modulo here to check whether I can make this. Means when the I will be 11 and there is 1 present in my map, then I can make this 11. Why? Because when I will add plus 5 in the 6, which was the original element of the array, I can make this 11. So I hope it is clear now. That's why I'm doing this I modulo value here again. And if this condition is not valid, then it means the value is present in our map. Then we will remove, simply we will subtract the frequency of that element, and if the frequency of that element is 0, then we will remove the add key from the map. So the else block will tell us that we can make the current ith element by subtracting or adding this value in our array. And this I am incrementing this I counter. So this is the solution for this problem, and the time complexity will be order of n, because we are simply iterating because O of n is taking here for adding the frequency in the map, and O of 1 in the worst condition we can take here O of n. So the overall time complexity will be O of n, and the space complexity will also be O of n, because we are using an unordered map.